Okay, forget the chicks. Some of you may have realized something. You may have realized that when we did 7 choose 2, for example, the number was 21. But some of you who have thought about the fundamental counting principle before, like for example, if you had me in Math 105 and we talked about this, you realize something like, okay, there's 7 spots we have to fill with 2 girls. We have to figure out all the possible ways to do this. So if you think about this, you have to think about placing the first bird down first. And this is the fundamental counting principle. How many ways can you do that? This is like rolling a die, a 7-sided die, and figuring out which of the spaces gets the first girl. Well, clearly there's 7 ways to do that. So let's for purpose of illustration, let's put her there. That's where the first girl is, right there in the middle. Now the second bird has to go in. But the second bird can't go in the same place the first bird went. She has to go into a different space. And there's 6 spaces left. So by the fundamental counting principle, the answer should be 7 times 6. Wait a minute, that's 42. 42. How the hell is that? I don't understand why that's 42. It's 42 because, let's say you put the second girl here. This math here treats putting bird 1 here and bird 2 here differently than putting bird 1 here and bird 2 here. So what you actually have to do is divide by 2 because you don't want to count that twice. And that's where the 21 comes from. It becomes more obvious when we look at the 3 case. 7 choose 3. Now, of course, you have access to Google. You can look up what 7 choose 3 is. But where does that number come from? Where do we get that number? Well, we can approach it again via the fundamental counting principle. Just like we did before. First, we have to place 3. We have to roll 3 dice, so to speak. Where's the first girl going to go? She's going to go there, and there were 7 ways for that to happen. Where's the second girl going to go? I don't know, let's put her here. But there were only 6 ways for that to happen. And where's the third girl going to go? I don't know, she was here. And there are 5 ways for that to happen. Now that number is way too big, because here's the deal. When you place these 3 X's, it doesn't matter what order you place them in, whether it's boop, 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 boop. I'm so sorry you had to hear that. But there are 6 ways for that to happen. Where'd the 6 come from? Well, this might not be inherently obvious, but you have 3 things. The way to put those in there in order is 3 times 2 times 1. That's where the 6 comes from. It's a factorial, which you learned about in Math 105. Now what's cool about this is we can actually do the divisions. And the answer, as you already saw, is 35. Which is where the 35 came from, both in Google and in the Pascal's triangle. Now some of you were like, okay Sean, what the hell? Where is all this, how is all this connected? Well, check this out. Okay friends, so these are the 4 we have calculated thus far. I'm going to start with this one. We'll come back up here to these. We can get them in a second. When we did this one kind of out, this was the first one we actually mathematically calculated. We ended up doing 7 times 6 divided by 2. And you know what? What the hell? I'm going to write this one out too. This one was 7 times 6 times 5 over, and I'm going to write this one actually as 3 times 2 times 1, because that's what we ended up figuring out last time. And this one, you could write it as 2 times 1 as well. Now look at this one and look at that one and realize the similarities. It looks like the denominator of these guys is this number factorial. And that's 100% correct. That's exactly what it is. And the reason that's there is to remove the ordering that you inserted into the X's. Because remember, we don't care whether we call them as like, that one there's a girl, that one there's a girl, that one there's a girl. Or if we say that one there's a girl, that one there's a girl, that one there's a girl. That's the same group. These are called combinations in the language of number theory, but that's not important for this class. What's important is this is the way to keep track of them. The same thing happens here with 7 choose 1. It was 7 over 1. So you can see what's happening. This is the oddball, and we'll come back to that in a second, I promise. It would continue with 7 choose 4. 7 choose 4 would be 7 times 6 times 5 times 4 over 4 times 3 times 2 times 1. So it's pretty clear that in each of these, you've got the denominator, which is the factorial of whatever the choose number is. So the factorial of the number chosen is going to be in the denominator. And that is exactly correct. But what's in the numerator, right? What's in the numerator? What goes up top? Well, if you look at this one, it's like if we think about factorials, which is what we've been kind of chatting about here, if you think about factorials, it's like you started 7 factorial, but you stopped after 2 numbers of the factorial. It's like you started 7 factorial, but stopped after 3 numbers. And mathematically, that's an interrupted factorial. Stop after number chosen factors. Now that doesn't look like a math formula, but it sure as hell is. I'll demonstrate in a second. But the reason I'm saying stop after number chosen factors is, like, with 1, you stopped at 7. With 2, you stopped at 6. With 3, you stopped at 5. Let's look at one of the ones we haven't done. I'm going to leave this one on the board, but instead do 7 choose 4. Okay, using our little handy-dandy formula, that means we're going to go 7 times 6 times 5 times 4 divided by 4 times 3 times 2 times 1. Now, what's cool about this is, we remember figuring this out. This was 35. What's this equal to? Well, those divide off that divides off that, that's 35. That should be 35, because choosing 3 girls and 4 boys is the same thing as choosing 3 boys and 4 girls when it comes to placement of where those are. Again, the symmetry of Pascal's triangle shows through, which is pretty rad. This is my go-to formula for how to figure out these binomial coefficients. There is another one. I'm going to put it here really quickly on the screen. Okay, there it was. If you want, you can go back and pause and take a look at it. I've tried to teach that one for years, unsuccessfully. I just like that formula because it makes the most sense, because you can see where it comes from. The other one makes sense too, but in the other formula, I'm not going to talk about it because I don't want to talk about it. If you want to talk to me about it, you can send me an email, we can chat. This, I think, is a much, much clearer way of coming up with those coefficients. The only one it doesn't do a very good job at. It does a great job for all of them, except for 7 choose 0. That's the only one, because you know that 7 choose 0 is 1. You know that. But if we try to use the formula on this one, I mean, how do you go down no spaces in 7 factorial? And better yet, how do you do 0 factorial? Right? That's the denominator, 0 factorial. Well, if you want to lose some sleep, Google why 0 factorial equals 1. That's a good one. There is no simple answer as to why why 0 factorial equals 1. There's no simple answer. It has to do with something called the gamma function, which is what the factorial is a subset of. But even saying that out loud to you, I feel like a fraud. Which is why, for anything other than choosing 0, this formula's bomber. And for choosing 0, just think. If you've got a bunch of stuff and you have to leave them all alone, how many ways can you leave them all alone? 1. Walk away from them. Simple. Simple, logical, and not buried in a bunch of jargon. All right, my friends, I hope that helped you understand the binomial coefficient and how to calculate them. Realizing, of course, you don't need to ever calculate them anymore. We have technology to do that for us, which is the whole point. The way I used to teach this was I teach them the formulas, and then I'd say, okay, now that we have the formulas, let's use technology. And then we'd never use the formulas again. And I began to think, I'm like, maybe the formulas aren't for everyone. They're just for folks that maybe want to see the inner workings of the math. And that's why you're here in this video. All right, go get them.